So given the Lagrangian that we saw before, we know that, well, we evaluate dl by dx. No such thing is there, so we have dl by x equals 0, and therefore it follows that dl by dx dot must be a constant. That's the momentum in the x direction, and that is m x dot plus theta 1 dot b cosine of theta 1 plus m x dot plus theta 1 dot b cosine theta 1 plus theta 2 dot b cosine theta 2 plus 2mx dot. So that's the momentum in the horizontal direction. That's a constant of the motion. Let's look at, so in other words, d by dt, dl by dx dot is equal to 0. And, well, what is that? That's mx double dot. Now we'll have second derivatives here. Theta 1 double dot b cosine theta 1 minus theta 1 dot squared b sine theta 1 plus m x double dot plus theta 1 double dot b cosine theta 1 minus theta 1 dot squared b sine theta 1 plus, it's a little tedious but clearly doable, theta 2 double dot b cosine theta 2 minus theta 2 dot squared b sine theta 2 plus 2m x double dot. So this becomes 4. All right, we have 1, 2, 3, 4, 4m x double dot plus mb times 2 theta 1 double dot cosine theta 1 plus acceleration of theta 2 cosine theta 2 minus b 2 theta 1 dot squared sine theta 1 plus theta 2 dot squared sine theta 2, and that is equal to 0. Okay, so that's the thing that's equal to 0. And our last equation, let's see, what do we have left here? dl by d theta 1 equals, well, d by dt dl by d theta 1 dot, and that looks like minus 2g sine theta 1 equals 2b theta 1 double dot plus 2x acceleration cosine theta 1 plus b theta 2 double dot cosine, well, given what we have, let's use this trig identity, plus b theta 2 dot squared, again, trig identity to make things easier, minus theta 2. And so this is what we get there, and then when we do dl by d theta 2, that's equal to d by dt dl by d theta 2 dot, that gives minus g sine theta 2 equals b theta 2 acceleration plus acceleration x cosine theta 2 plus b theta 1 acceleration. Let's use our trig identity. Theta 2, otherwise this becomes too long, plus minus b theta 1 dot squared sine of theta 1 minus theta 2. This is the other result. We just use the sine of theta 1 minus theta 2 equals sine theta 1 cosine theta 2 minus cosine theta 1 sine theta 2. Got the paper all wet, so I dropped some water, but let's try to write the other relation that we use, the cosine of difference in angles that they came from theta 1 and sine theta 2. Here we have a plus sign, sine theta 1 cosine, sorry, sine theta 2. I think that's right. Anyway, that should be correct.